we took a look at some of the polynomial stuff that we had done in grade 9, and we just reviewed that. Today we're going to move on to common factoring. So our goal is I know what a common factor is and can use it to rewrite an expression as a product. So going back to the last lesson, just a reminder of what we do to expand when we've got a term out in front and then an expression inside the bracket. So we have to distribute the 3. The 3 is to multiply by each part inside the bracket. So 3 times 4x is going to give us 12x. 3 times 6b will give us minus 18b. And 3 times 1 will give us 3. And that's as far as we can go. These are not like terms, so that's our final solution for that one. And then in this case, we've got a variable out in front that we're going to multiply inside. Very important to remember that when there is no exponent on a variable, there's actually a 1 there. So in this case, when I multiply x times 3x, it's going to be 3 out in front, but then I add the exponents on the x's and I get 3x squared. And then in the next part, it's going to be minus 4, and x and y are different variables, so they just get written beside each other. Usually we write those in alphabetical order. And then x times 7 is going to be 7x. So that's a little bit of review from the last topic that we covered. And here's the reason that we just took a look at that is because factoring, which is what we're going to start looking at today, is the opposite of expanding. So if we think about this question here on the left, if we're going to expand this, we get 12a plus 16b. If I was going to factor 12a plus 16b, it's equal to 4 times 3a plus 4b. So notice the connection here. When we expand it, we get rid of the bracket and write the expression like this. When we factor, we're doing the opposite of expanding. We're trying to write the expression as the product.
Could David Dake please go to the music room? David Dake to the music room, please.
We're trying to write the expression, this expression here, as a product of 2 expressions. Okay, and the next one here, we expand. So a times b is going to be ab. And then a times minus b is going to be minus ab. And notice in this question that there's an a in both parts here. So that's what ends up going out in front of the bracket. And again, you can see that one is just the opposite of the other. So we have 3 terms inside the bracket, so 3 multiplications. So 4 times 2 will be 8, and then we add the exponents on the x's. And then minus 4, and then we add the exponents on the x's. And then 4 times 5 is 20, and then there's just an x squared there. And I think you probably get the picture now. This is going to look exactly the same as the question on the left-hand side there. Okay? So what you see on the right-hand side here, that's what we're going to be looking at today, is how do we do those factoring questions. Okay? So common factoring involves removing a common divisor of all the coefficients, so all the numbers, and removing any common letters. And remember, letters, we mean variables from all terms. So that section on the right up above, that's exactly what we're doing, removing a common divisor of all the numbers or coefficients and removing any common letters or variables from all terms. That term that we remove is called the GCF, which stands for greatest common factor. So let's take a look at some examples here. So in the first one here, we have to start by finding the biggest number that will divide into both 5 and into 10. Okay? Now, some students will think, oh, it has to be 10. But 10 won't divide into 5. It has to be a number, it's got to be a common divisor. So a number that divides into each of these. And in this case, that's 5. And then we check to see if there's any letters that are common to both terms, and there aren't. So 5 is our greatest common factor. And then we have to figure out, what do we multiply? What do we multiply? Let's move that down. What do we multiply 5 by to get 5y? So it's like we are dividing 5 out from that, and we get y. So if I divide 5 out of there, I get y. And then I have to divide 5 into minus 10, and I get minus 2. And if I turned around and expanded this, I would get back to the question that I started with. So 5 times y gives me 5y, and 5 times minus 2 gives me minus 10. Okay, and the next one, 6. It's common to both terms. It's the common divisor that works in both those numbers. And there's no letter that's common to both. So I'm going to divide each of these by 6. And when I divide 6 into 12, I get 2. That's going to be 2a. And when I divide 6 into 18, I get 3. And that's a plus 3. So that's what that looks like. Now those two are pretty straightforward. We're only dealing with a couple of terms. And we're just taking a number out as a common factor. So it will get a little bit more challenging, but that's the basic idea of what we want to do. So when I look at these three terms, 2 divides into each number in front. And these first two terms have a's in them, but the last term doesn't. So I can't use a as a common factor here. So I want to divide each term by 2. Now I'm showing this step in these questions. Eventually you guys can do this in your head. You don't have to write down the divide by 2. But if I divide that first term by 2, I get a squared. So 2 times a squared gives me 2a squared. And then I've got a minus 5a. So 2 times minus 5a gives me minus 10a. And 2 divided by 2 is just going to be 1. And 2 times 1 gives me that 2 there. Okay, so the nice thing when you common factor is that you can check your answer to make sure that it works by doing the opposite, expanding your answer and seeing if it takes you back to your question. So in this one here, we've got a little bit of a problem because there's no number that divides evenly into those three numbers. Okay? We never talk about 1 as a common factor, so you know the last one, 2, is our common factor, Here, there's no number that divides into 3, 4, and 7. So now we're checking the letters. And the letters, there's a W in each term. So we take W out, and then we need to check and see what the smallest exponent on common letter is used in greatest common factor. So in this question, we've got a 1, we've got a 2, and we've got a 3. So our greatest common factor is the smallest of those exponents. So it's W to the exponent 1. You don't have to write the 1 there, but I'm going to write it there for this question. So now, if I divide each of these, I do a better job of leaving room for myself here. Okay, so if I divide each of these by just W, then I'm going to get 4, because the W's will divide each other out. And then in the next one I get plus 3. Now remember, I need to subtract the exponents, so 2 minus 1 is going to give me 1. And then W on the end here is going to be minus 7. Just move this guy a little bit. So minus 7, and then it's going to be W squared. And again, I encourage you, when you get your answer, to go ahead and check and see that when you expand this, so when you use the distributive property, you get back to the original question. Okay, so in this one here, 7 divides into all 3 numbers. And then the smallest exponent on K is 3. So we're going to get, we divide each of these by 7K3. We're going to get 7K squared minus, now these two are identical, 7K cubed and 7K cubed. Now they don't disappear. When we divide two things that are identical, we get a 1 there. So that's going to be minus 1 and minus 5K. Okay, I'm going to do one more now, and then we'll try the others in class tomorrow. Okay, so here, there's just a 1 in front of here, so there's no number part of our greatest common factor, but all 3 terms, have an A in them, and the smallest exponent on A is 1, and all 3 terms have a B in them, and the smallest exponent on B is 1 as well. So I'm going to divide each of these terms by AB. So in the first case, the 12 I'm going to need, and then A squared divided by A is going to be A, and then B divided by B is just equal to 1. So we get 12A there, minus 24. A divided by A is fine, and then B squared divided by B is going to be B. And then on the end, AB divided by AB is just going to give me a 1 on the end. Okay, I'm going to stop there, and we'll try the other 3 in class tomorrow. Thanks.